Hello, this is Mr. Combs, and we're going to talk about factoring again this week. And if you remember, we have the factoring list, what I like to call the factoring list. And we've already looked at two steps on the factoring list. The first one we are going to apply to all polynomials that we try to factor, and that is to factor out the GCF. And after you do that, or if you can't do that, then the second step, we can only do the second step if we have four terms. But if you have four terms, you're going to try factoring by grouping. All right? But let's look at something like this. Let's look at x squared plus 6x plus 5. Okay. So if I'm looking at x squared plus 6x plus 5, I go down the factoring list. Factor out the GCF. Well, there's not an x in all of them, so I can't get an x out. 1, 6, and 5, those are all, I mean, they don't have any common factors, so they're all, they don't have anything in common. So I can't factor out the GCF. There are three terms. This is a trinomial instead of four, so I can't do step 2. So it must be time for step 3. And step 3, you can only apply step 3 if you have a trinomial. And furthermore, your trinomial has to be of the form x squared plus ax plus b, where x squared must have a coefficient of 1. Okay? So, trinomial x squared plus ax plus b, x squared must have a coefficient of 1. So you couldn't have a number in front of x squared. So if I had something like 4x squared plus 6x plus 5, can't do this step. You have to move on to another step. Okay? Alright, so let's take a look at these kinds of problems. Let's go back to multiplication for a minute. Let's say I have the two binomials x plus 1 times x plus 5. Okay, if I have x plus 1 times x plus 5, I know how to do this. I know how to multiply. I'm going to say x times x, and that's going to give me x squared. I'm going to say x times 5, and that's going to give me 5x. I'm going to say 1 times x, and that's going to give me x. And 1 times 5, and that's going to give me 5. When I add these all together, I'm going to get, or when I add the two middle terms, not all these together, the two middle terms because they're like terms, then I'm going to get x squared plus 6x plus 5. So we see that when we multiply two binomials, sometimes or often we get a trinomial. Okay? So what we're going to assume is that a trinomial will break down into two binomials. Okay? So we're going to assume that we're going to have two binomials multiplied by each other. Alright? And then we just need to actually fill in the terms of our binomials. Well, the first term in each binomial is going to be easy because how can I get an x squared? An x times an x. So notice that x times x will give me x squared. So that's where this x comes from. And then how can I get a 5 when I multiply? Well, I can get a 1 and a 5, but when I choose the 1 and the 5, I have to make sure that when I add these two numbers together, they'll give me the middle term, because I have to add them when I'm multiplying, right? And 1 plus 5 will give me 6, and there's a positive 1 and a positive 5. So basically, x plus 1, x plus 5, that is the factored form of x squared plus 6x plus 5. Okay? All right? So let's actually organize this a little better, and let's write a list of steps for doing this. And then we'll look at factoring another polynomial as we're looking at the list of steps. So let's take this polynomial. A squared plus 11a plus 30. The first thing we're going to do, if we want to factor we'll say in general x squared plus ax plus b. Actually, I don't need this. I need to get rid of that. Okay. The first thing we're going to do is we're going to write x and x in parentheses. So we're going to write this. Okay? And the reason why we do that is because this x and x will form the x squared, right? So now in our example we have a's, so I'm going to go ahead and write a and a in parentheses. Now in the second step, what we want to do is we want to fill in the blanks with two numbers that add to get the coefficient of the x term. So we want to, and what I usually do is above this I write a little plus. We want to get two numbers that when you add them together, you get the a here. You get the coefficient of the x term. But when you multiply, so the two numbers need to add to get the coefficient of the x term and multiply to get the constant. So they need to multiply to get this term. Okay? So if you want to put above each of your polynomials when you're factoring a little plus and a little multiplication symbol, that's a good idea. That's actually what I would do. So now I need to find two numbers that when I add them together I get 11. When I multiply them together I get 30. Now this is sometimes easier than it is other times, depending on what your two numbers are. So what I like to do is I like to look at all of the ways that I can get 30, positive 30, when I multiply. I can get positive 30 by saying 30 times 1. Can't forget our negatives here. I get positive 30 by saying negative 30 times negative 1. I can get positive 30 by saying 5 times 6, or negative 5 times negative 6. I can get positive 30 by saying 3 times 10, or negative 3 times negative 10. I can get positive 30 by saying 2 times 15, or negative 2 times negative 15. Is there any other way that I can get 30? I think that might be it. Now what I'm going to do is I'm just going to go down the list, and if a pair gives me 11, then that's the pair of numbers I want to use. 30 plus 1 is 31. That's 11. That's not 11, so get rid of that. Negative 30 and negative 1, that's negative 31. That's not 11. 5 plus 6, 5, 6, 7, 8, 9, 10, 11. 5 plus 6 is 11. So that's exactly what I want to use, a positive 5 and a positive 6. So a plus 5, a plus 6 is our full factored form. So remember, you basically just write x and x in parentheses, fill in the blanks, two numbers that'll give you the constant term when you multiply, and the x term or the variable raised to the first power term when you add. That's basically it. Let's look at several more examples. What if I have y squared minus 11y plus 10? Alright, let's look at these. So y squared minus 11y plus 10, it's a trinomial. There's nothing in common. So I can't do step 1. I'm going to skip step 2 because I don't have 4 terms. So I come to step 3 and I'm going to put y and y in parentheses because y times y will give me y squared. Now I need to look at two numbers that will give me 10 when I multiply, but negative 11 when I add. So how can I get 10? I can get 2 times 5, negative 2 times negative 5, 1 times 10, negative 1 times negative 10. Those are all the ways that I can get 10 when I multiply. I think that might be it. So 5, 6, 7, 5 plus 2 is 7. That's not going to work. Negative 2 and negative 5 is a negative 7. That's not going to work. 1 plus 10 is 11, but now I need a negative 11, so that's not going to work. But a negative 1 and a negative 10, that will, when I add them together, give me negative 11, so those are the numbers I need. Negative 1, negative 10. Remember, you can always check factoring by multiplying. All right, let's look at several more. Let's look at x squared minus 2x minus 99. There's nothing in common to all three of those terms. I don't have 4 terms. I do have a trinomial. So let's factor by writing x and x in parentheses and filling in the blanks. Alright, so I have a negative 2x and a negative 99. Let's see. I need to find two numbers that when I multiply them together I get negative 99, but when I add the two numbers together, let me make that a little bit better. That plus is not very good. So when I add the two numbers together, I get negative 2. So let's look at all the ways I can get negative 99. Negative 99 times 1, or 99 times negative 1. Negative 9 times 11, or 9 times negative 11. 3 times 33, well, negative 3 times 33, or 3 times negative 33. What else? Let's look at those for now. There may be others. I can't think of any right off the bat, but so negative 99 times 1 is negative 99, but negative 99 plus 1. Now remember, when you're looking at finding a negative 2, you're adding these together. So negative 99 plus 1 will be negative 98. That's not going to work. 99 plus negative 1 is going to be 98. That's not going to work. Negative 9 plus 11, that's going to be 2. Well, we have 2, but we need a negative 2, so that one's not going to work. So 9 plus negative 11 That's going to give me negative 2, so that's the two numbers I need to use. I need a positive 9 and a negative 11. All right, let's look at a couple more, and then I'll give you a chance to look at some on your own. So let's look at one like this. What if I have 3x cubed minus 63x squared minus 300x? All right, the first thing I'm going to do is I'm going to determine if there's anything in common. Well, as soon as I see 363 and 300, I know all of those are divisible by 3, right? So I'm going to take a 3 out of there. And I also notice that there is at least one x in each of these. So I can take out the smallest, which is x to the first. So I can take a 3x out. So before I even look at step 2 or 3, I can already take a 3x out. So that's going to leave me with x squared minus 63 divided by 3 is 21. X minus 300 divided by 3 is just 100. And I only had one x and I took it out, so I don't have any x's. Alright, so 3x times x squared minus 21x minus 100. Now if I look at this polynomial that I have left, I only have 3 terms. I don't have 4 terms, so I can't do step 2. So let's try step 3. So I'm going to break this down into x and x in parentheses, and I need to fill in the blanks with two numbers that will multiply to give me 100, but will add to give me negative 21. I guess multiply to give me negative 100, but will add to give me negative 21. Let's see. So how can I get 100? Let's see. I can get 100 by saying 100 times negative 1 will give me negative 100, or negative 100 times 1. 20 times negative 5 will give me 100, or negative 20 times 5. 25 times negative 4 will give me 100, or negative 100, or negative 25 times 4 will give me negative 100. Let's see, 10 times negative 10, or negative 10 times 10 will give me 100. Let's see. I think that's enough for us to look at. So 100 or plus negative 1, that's just going to be 99. Negative 100 plus 1, that's going to be negative 99. It's not going to work. 20 plus negative 5, that's going to be 15, right? That's not going to work. Negative 20 plus 5 is going to be negative 15. That's not going to work. 25 plus negative 4, that's going to give me 21, but look here, I need a negative 21, so that's going to give me a positive 21. That's not going to work. So that must mean that negative 25 times 4 is what we need to use, because negative 25 plus 4 will give me negative 21. So it is a negative 25 and a positive 4. And then the full factored form would have to include this 3x. So I'm going to bring this 3x down, and this entire expression, 3x times x minus 25 times x plus 4, is the full factored form. All right? Okay, let's look at one maybe a little different. Okay? Let's say I have something like this. A squared minus 12ab this time plus 49b squared. Just a second. Okay. Sorry about that. Had to answer the phone. Alright. So if we're looking at a squared minus 12ab plus 49b squared, you're probably thinking to yourself, hey, wait a minute, I've got this b and this b squared. I don't know about that. Well, I'm telling you, it's going to work just like the other examples we've been doing, except that now instead of just writing a and a in parentheses, a times a is a squared, we'll also need to put b in parentheses at the end there. So it works exactly the same. We just need to add that extra b because b times b will make b squared. Okay? I'm still going to try to find two numbers that when I multiply them together, I get 49, and when I add them together, I get negative 12. Okay, so let's see. So 49. 49 is, let's see, 7 times 7 will give me 49, and negative 7 times negative 7 will give me 49. I know that 1 times 49 will give me 49, and negative 1 times negative 49 will give me 49. That may be it. That may be it. Let's see, 7 times 7, negative 7 times negative 7, 1 times 49, negative 1 times negative 49. Okay, 7 plus 7 is 14. It's not negative 12. Negative 7 and negative 7 is negative 14. That's not negative 12. 1 and 49 is 50. That's not negative 12. And negative 1 and negative 49 is negative 50. That's not negative 12. So this must be not factorable. And I'm kind of glad we did that, did this one, because we got to see something that was not factorable. But I also want us to see something that works out too. So let me see if I can find another one real quickly here. Let me see. What if we have something like this? Y squared plus 12xy plus 27x squared. Okay, let's try to factor this. Alright, so what we're going to do is we're going to look to see if I have anything in common. I don't have anything in common. I don't have 4 terms, I just have 3. So I'm going to try to factor this as a trinomial, y and y in parentheses to get y squared, but then also I need to put x and x in parentheses as well. Okay. Alright, now let's find two numbers that when I multiply them together I get 27, but when I add them together I get 12. So how can I get 27? Well, 1 times 27, negative 1 times negative 27. 9 times 3, negative 9 times negative 3. That might be it. 2, 4. Okay, let's try these. 1 plus 27 is 28. That's not going to work. Negative 1 and negative 27, that's negative 28. It's not going to work. 9 plus 3, 9, 10, 11, 12 is 12. 12 is what we need. So a positive 9 and a positive 3 is what we've got. So I've got y plus 9x times y plus 3x. That's it. Alright, cool. Let me let you try some. Alright, so what if I ask you to factor the following? X squared plus 7x plus 6. What about b squared plus 5b plus 4? What about a squared minus 4a minus 12? What about x cubed minus 6x squared minus 16x? What about x squared minus 14x plus 49 and x squared minus 7xy plus 9y squared? Now push the pause and try each of these. Okay, if you need more time, then push pause until you're finished. I really hope that you try each one of these. So let's first look at x squared plus 7x plus 6. Nothing in common. I don't have 4 terms, so I go on to step 3, and I'm going to write x and x in parentheses. And what I need to do is find two numbers that when I multiply them together, I get 6, and when I add them together, I get 7. Alright, let's see. 6 times 1, negative 6 times negative 1, 2 times 3, negative 2 times negative 3. Those are the ways that I'm going to get 6 when I multiply. So now let's add. What is 6 plus 1? 7. That's what I needed. So a positive 6 and a positive 1. So this factors into x plus 6, x plus 1. That's my full factored form. Alright, let's look at b squared plus 5b plus 4. Again, I don't have anything in common. I don't have 4 terms. So b and b in parentheses. Two numbers that when I multiply them together I get 4, but when I add them I get 5. Probably 4 times 1. So b plus 4, b plus 1. That one wasn't so bad. Alright, let's look at this one. A squared minus 4a minus 12. A and a in parentheses, because I don't have anything in common. I don't have 4 terms. So let's see, 12. How can I get a negative 12 this time? So a negative 12 is negative 6 times 2, or 6 times negative 2, negative 3 times 4, or 3 times negative 4, 1 times negative 12, or negative 1 times 12. I could go on. But I need to add a pair of these numbers together and get negative 4. So negative 6 plus 2, what's that? Negative 4, so that works out. So it's negative 6 and a positive 2. And that's it. So a minus 6 and a plus 2. Alright, let's look at x cubed minus 6x squared minus 16x. What is in common here? An x, right? So I can factor an x out. And when I do that, I have x squared minus 6x minus 16. So how can I get 16? Well, let's see. Negative 16. Negative 1 times 16, or 1 times negative 16. 4 times negative 4. or negative 4 times 4. 8 times negative 2, or negative 2 times 8. Is 16 divisible by 3? I don't think so. So I think that might be it. Negative 1 plus 16, that's not going to work. That's going to give me 15. 1 plus negative 16, that's going to give me negative 15. That's not going to work. 4 and negative 4, that's going to give me 0. That's not going to work. What's 8 and negative 2? That's 6, but I need negative 6, so that's not going to work. And actually here I made a mistake. That shouldn't be negative 2 and 8. That should be a positive 2, sorry, and a negative 8. All I did was switch the numbers around instead of switching the signs. So a 2 and a negative 8, that's going to give me negative 6. So x and x in parentheses, and a 2, positive 2, and a negative 8. And I can't forget to bring my x down, so I have x times x plus 2 times x minus 8. There we go. Alright, let's look at the next one. I've got x and x in parentheses because I don't have a common factor and I don't have 4 terms. The way that I can get 49, so in 49 I need to multiply to get 49, but to add to get negative 14. So 7 times 7 is 49. Negative 7 times negative 7 is 49. And I notice that negative 7 times negative 7 will give me negative 14, so x minus 7 and x minus 7. We can leave it this way, x minus 7 times x minus 7, but sometimes the cool kids will write this as negative, or as x minus 7, squared. So either way, either one of these is perfect. Alright, and let's finally look at this last one. So, nothing in common. I don't have 4 terms, so I'm going to write x and x in parentheses, only in this time I notice that I have xy in the middle and a y squared, so I'm going to write y and y as well in parentheses. 2 numbers that when I multiply them together, I get 9, but when I add them together, I get negative 7. So let's see, 1 times 9, 3 times 3. Negative 1 times negative 9, negative 3 times negative 3. Are there any other multiples of 9? I don't think so. So 1 plus 9 is 10. 3 and 3 is 6. Negative 1 and negative 9 is negative 10, and negative 3 and negative 3 is negative 6. None of those will be negative 7. So again, I think this is not factorable. And sometimes if a polynomial is not factorable, we call it prime. So either one of those will work, prime or not factorable. Alright, let's take a look now at something like this. Three x squared minus 10x minus 8. Alright, so 3x squared minus 10x minus 8. Okay, so on the factoring list, if you'll remember the factoring list, First step, factor out the GCF. Let's see, 3x squared, negative 10x, negative 8. There's nothing that they all have in common. So second on the factoring list, I want to check to see if I have 4 terms. If I do have 4 terms, then I can try factoring by grouping. I don't have 4 terms, I only have 3 terms. If I have a trinomial, and it's of the form x squared plus ax plus b, where there's no number in front of x squared or the coefficient of x squared is 1, then I can try to write x and x in parentheses and fill in the blanks. Well, I don't have any of those situations in this polynomial. I have a number in front of x squared. So step 4 on the factoring list is for a trinomial where you have a number in front of x squared. And the way that we're going to factor this, we're going to call it trial and error, but we're going to use something called the z-box to help us. Okay, so trial and error and the z-box. So let's talk a little bit about what that is. All right, we know that a trinomial factors into 2 binomials. Okay? So in this case, what we have to find is we have to find 2 terms that I can put here and here, that when I multiply them together, I get 3x squared. We also need to find 2 terms to put here and here, that when I multiply those 2 together, I get negative 8, right? You'll agree with me there, right? But we also need to find terms such that when I take the first and the last and multiply them with the 2 inner terms, I need to be able to add those together to get negative 10x. That's confusing. You're confused by that, I'm sure, because I'm confused by that. That's a little confusing. So we're going to do trial and error. We're going to just pick and choose, but we're going to use a way of writing it down that makes it a little bit easier, and that's the z-box. So when you use the z-box, what you're going to do is you're going to draw sort of like a boxy z, just like that. Alright, so I'm going to put the leading term and the constant term on top, and I'm going to put the middle term or the x term on the bottom. Now my goal is going to be to break up 3x squared into 2 factors, break negative 8 up into 2 factors. When I multiply across and add, then I should get negative 10. If I've done that, then I have the factors that I need. Okay? Alright, so let me erase this, and we'll see how this works. Okay, so the first thing that we're going to look at is 3x squared. How can I break up 3x squared? Well, I might be able to break it up into 3x and x. As long as these 2 things will multiply to give you what's on top, there's no wrong answers. Okay? Well, now let's look at negative 8. How can I break negative 8 up? Well, I could break it up into negative 4 and 2, right? Negative 4 times 2 is negative 8. Now what I want to do is multiply across and add to see if I get negative 10. So 3x times negative 4x is negative 12x, and x times 2 is 2x. Negative 12 plus 2 is what? Negative 10. It works out. It just so happened that this worked out on the first try. If it didn't work out for us, then we would just erase and try another 2 factors. But this one did work out. So when that happens, the 2 diagonals form your binomial factors. So 3x and 2 and x and negative 4. So this factors as 3x and a positive 2 times x and a negative 4, x minus 4. So there you go. That's factoring using the Z-box. We'll do several more examples. All right, let's look at this example. What if I have 10x squared plus 37x plus 7? All right. Well, I know that I need to factor this into 2 binomials because it's a trinomial. There's nothing in common. It doesn't have 4 terms. There's a number in front of x squared. So we're still dealing with step 4. So I'm going to use the Z-box. Okay. I'm going to put 10x squared up here and 7 here. I'll put 37x there. All right, how can we break 10x squared up? Well, we could break it up as 2x and 5x. 5 times 2 is 10, and x times x is x squared. And how can I break 7? I could break 7 up as let's say 7 and 1. Okay, so 2x times 7 is 14x. And 5x times 1 is just 5x. 14x plus 5x, that's 19x. Nope, these can't be the factors because, or this can't be the combination of factors because 14x plus 5x equals 19x. That's not 37x. That's what we need. So let's get rid of that. It's a good idea. It is a good idea to do these things in pencil so you can erase. And so you look at this, and why don't I try first just switching around the 1 and the 7. So instead of saying 7 and 1, let's say 1 and 7. So 2x times 1 is 2x, and 5x times 7 is 35x. So 35 and 2 is 37. That's what we want. So our diagonals form the binomial. So 2x and a positive 7 and 5x and a positive 1. And it doesn't matter which you write first. You could write 5x plus 1 first and 2x plus 7 second. It doesn't matter. But there you go. The Z-box is kind of fun. I always like to say Z-box because to me it sounds like somebody French trying to say the box. So what is this? Oh, well, this is the Z-box. So anyway, All right, let's look at another one. Let's just do several examples. So what if I have 24x squared minus 76x plus 40? All right, the first thing I notice in this case is that I have common factors. 24, 76, and 40. I know they're all divisible by 2, but I'm thinking since 24 and 40 is divisible by 4, that 76 might be as well. So I'm going to use my calculator because I don't know that right off. 76 divided by 4 is 19. So there's a 4 in common here. So if I divide everything in parentheses by 4, I get 6x squared minus 19x plus 10. Now, inside parentheses, I don't have 4 terms. I have a trinomial. I have a number other than 1 in front of x squared, so I want to use step 4. And so to use step 4, we're still going to break this down into 2 binomials. But to help organize our thoughts, we're going to use the Z-box. Z-box. All right. So I'm going to say 6x squared and 10 and then negative 19 here. Okay, how can I break up 6x squared? How about 2x and 3x? How can I break up 10? How about 2 and 5? One of the things I notice is that I have a 19. Oh, I forgot my x there. I have a negative 19. So I need to have these numbers be negative. These numbers here, these terms here, I need them to be negative. Or I need it to add up to be a negative number. So let's make the 2 and the 5 negative, just because a negative 5 and a negative 2 is a positive 10. So 2x times negative 2x now is negative 4x. And 3x times negative 5 is negative 15x. Fortune smiles upon us because negative 4 and negative 15 is negative 19. So that's what we need. So my binomials are 2x minus 5, or 2x and a negative 5, and 3x and a negative 2, or 3x minus 2. So I can't forget about my 4, so I bring 4 down, and this is the full factored form. Okay, what if I had something like this? 2x squared plus 7x minus 4. There's nothing in common. Don't have 4 terms. I have a number in front of x squared, so it's time for step 4. So I want to use the z-box. I know I'm going to break this up into 2 binomials. So 2x squared and negative 4 and 7x. So 2x squared I can break up into 2x and x. Negative 4, let's see, I can break it up into negative 2 and 2. So 2x times negative 2x is negative 4x, and x times 2 is 2x. Negative 4 plus 2 is not 7, so something's wrong. I don't have the right factors, so let me get rid of these. Let me try something else for negative 4. Because 2 times 1 is basically how we're going to get 2. So let's see, negative 4. Let's try 4 and negative 1. Okay, so 2 times 4 is 8. 2x times 4 is 8x. And x times negative 1 is negative 1x. 8 minus 1, or 8 plus negative 1, is 7. So 2x minus 1 and x in a positive 4, or x plus 4, that's our full factored form. That's our factored form. What do you think? Let's try just a couple more. What if I have 18x squared plus 21x minus 9? I think all of these may have a common factor. I think they might have a common factor of 3. So I'm going to take a 3 out. 18 divided by 3 is 6x squared. 21 divided by 3 is 7x. Minus 9 divided by 3 is 3. So 6x squared plus 7x minus 3. I don't have 4 terms. I have a number in front of x squared, so I think it's time for step 4. So I'm going to use the z-box to help me. So I'm going to put a 6x squared there and a negative 3. I'm going to put 7x on the bottom. Let's see, 6x squared, I can break that up into 2x and 3x, right? And 3, I can break that up into, well, it's negative 3. So how about 3 and negative 1? So 2x times 3 is 6x. And 3 times negative 1 is negative 3x. Six minus 3, or 6 and negative 3. That's not 7, so I've done something wrong here. I've done something, have some factors wrong. So let's make it what about 1 and negative 3? So I have 2x times 1 is 2x. And 3x times negative 3 is negative 9x. And here is a problem, because this 2 and negative 9 will give me negative 7. I want a positive 7. But notice that if I take this negative, and I put it up here on the 2, then that'll work out. That makes 7. Negative 2 plus 9 is 7. So that means here I've got to take away this negative and put it on the 1. So in this case, I have 2x plus 3 and 3x minus 1 as my two binomials, and I can't forget about my good buddy 3 there. He comes on down. So this is the full factored form. You'll get lots of practice with this in the homework. Let's look at one more together, and then I'll let you try some. So what if I have 3p squared minus 16pq minus 12q squared? Well, let's see. I know that, well, let's see. 3, 16, and negative 12. Nope, I don't think that 16 is divisible by 3. And 3 is not divisible by 2. So I don't think that there are any common factors. I don't have 4 terms, I only have 3. I have a number in front of p squared, so I'm going to break this up into 2 binomials. But I'm going to use the z-box to help me. So I have 3p squared and negative 12q squared. And here I have negative 16pq. Alright, so I can break 3p squared up into 3p and just p. But how can I break negative 12 up? Negative 12q squared. What about a negative 3q and a negative 4q? So the only thing that makes this different from the other ones that we've been doing is that we're going to have a q on the end. Just like with the polynomials, the step 3 polynomials, the only thing that changes is you have that extra variable on the end. The same way is going to be with these, but every other thing about these stay the same. The method stays the same, and what we're looking for stays the same. So let's see, 3 times negative 3 is going to be negative 9 PQ. And P times negative 4 is negative 4 PQ. So 9, 10, 11, 12, 13. That's only negative 13. I need negative 16. So something's wrong. Something's going on. Let's see. Why don't we, because this has helped us before, switch these around? Actually, you know what I did? This is a good teachable moment here, because I said negative 12. That doesn't break down into negative 3 and negative 4. Only one of these can be negative. Right? So let's take a look at that again. That's negative 9Q. And that's 4Q. Well, that's even worse. That's just negative 5. Right? So that's not going to work. So let's get rid of this. Let's get rid of these. And let's switch these around. Let's look at 4Q and 3Q. Let's make one of them negative. Let's make the 3 negative maybe. So 3 times 4 is 12Q. 3P times 4 is 12PQ. And P times negative 3Q is negative 3PQ. 12 minus 3, that's not 16. So something else is wrong here. 3 and 4. Probably can't use 3 and 4. Let's see, what else could we use? How about 2 and 6? Let's try a negative 6 and a 2. So negative 6Q and 2Q. 3 times negative 6. 3 times 6 is 18, so that's negative 18 PQ. And P times 2Q is 2PQ. Negative 18 plus 2 is negative 16, so that's exactly what we need. And that one we had to work on a little bit. So don't give up too easily, because sometimes you have to work on them a little bit. So 3P plus 2Q and P minus 6Q. That's the factored form. Alrighty, let me give you something to work on. And then, so after I write these down, push pause and try to work them out on your own. So let's try 12t squared minus 6t minus 6. Let's try 2t squared plus 5t plus 2. Let's try 6x squared plus 33x plus 15. And let's try 9a squared plus 18ab plus 8b squared. Try those. Alright, if you still need some more time, just push pause again, but let's take a look at these. So 12t squared minus 6t minus 6. Well, there's something in common there, right? I can get a 6 out. So that's going to leave me with 2t squared minus 1t minus 1. I still need to factor this into two binomials, but I'm going to use the z box. So I have 2t squared, negative 1, and negative t. Well, 2t squared, 2t and t, and then let's see, negative 1, how can I break negative 1 up? Well, it's only going to be 1 and 1, because 1 times 1 is 1, but which one should be negative? How about the first one negative? If I make the first one negative, I have 2t times negative 1, that's negative 2t, and I have t times 1, that's t. Negative 2t plus t is going to be negative 1. That's it. That's what I need. So this is going to be 2t plus 1 and t minus 1. And then I'm going to bring down my 6. So this is the factored form. Alright, cool. Let's look at this next one here. So 2t squared plus 5t plus 2, nothing in common. I don't have 4 terms. I have a trinomial, but I have a number in front of t squared. So I'm going to break this down into two binomials, but I'm going to use the z box to help me. So 2t squared, 2, and then 5t. So 2t and then just t would be a way that I can break up 2t squared. And 2 and 1 would be a way I could break up 2. 2 times 1 is 2. So 2t times 2 is 4t. These are too easy. And then t times 1 is just 1t. 4t plus 1t is 5t. That's it. So 2t plus 1 and then t plus 2. And that's the factored form right there. Alright, let's try another one here. This 6x squared plus 33x plus 15. I can get at least a 3 out of this, right? So I'm going to have 2x squared plus 11x plus 5. So I'm going to break this up, but I'm going to use the z box to help me. So 2x squared and 5 and 11x. Alright, so 2x squared I can break up into 2x and x. 5 basically is 5 and 1. 2x times 5 is 10x. X times 1 is 1x. That makes it 11. So 2x plus 1, x plus 5. And bring down your buddy 3. This is the full factored form. Alright, one last one. So 9a squared plus 18ab plus 8b squared. 9 and 18 have common factors. 18 and 8 have common factors, but I don't think that there are common factors for all three of these. So I know, though, that I want to make two binomials, but I'm going to use, since I have a number in front of a squared, the step 4. So 9a squared, 8b squared, 18ab. Let's see. Uh-oh. I was thinking here. How can I break 9 up? What about 3a and 3a? That'll give me 9a squared. And what about 2b and 4b? 3a times 2b is 6ab. And 3a and 4b, 3 times 4 is 12ab. 12, 13, 14, 15, 16, 17, 18. 18, I got it on the first one. If you think about it a little bit, you can. So let's see, 3a plus 4b and 3a plus 2b. And that's the full factored form. Alright, I hope this video on factoring trinomials was helpful. If you have any questions, just give me a call or send me an email, or look in the Math Cafe, or post something in the Math Cafe. Alright.